Now we have vector into space. Okay, this one. We have two coordinate x1, x2. And vector in space more than two space lah, three space and above. Okay, vector can be represented geometrically as a directed line segment or arrows into space x1, x2 or three space x1, x2, x3 or more than three space. Okay, we look at this picture. Okay, vector has the initial point and the terminal point. Okay, for example, okay, we have this picture, this illustration. Okay, we have this vector in three space. Okay, we have x, y, and z. So the value for x is 2, y 3, and 5 is z. Value for z. Okay, the notation for vector can be represented in various ways, such as okay, this notation, this tree notation. Okay, this notation consists of direction of a vector. This one, the arrow and direction. Okay, vector u and v are said to be equivalent if they have the same length and direction. Same length and direction. Okay, length we also call the magnitude of a vector. And direction either positive or negative direction. Positive or negative direction. Okay, the vector is called a zero vector if all the components of a vector are zero. Means we have, for example, we have vector into space, a zero vector. Zero consists of 0, 0, 0. The coordinate is 0, 0. Okay, and the negative vector, negative v, is the vector that has the same magnitude as v, but in opposite direction. Negative direction. Okay, we have the three basic operation in vector. First, we look at the vector into space. Okay, there are three operations. Okay, operation number one, addition. Okay, the vector u plus vector v. Okay, so equal to, okay, we let vector u equal to u1, u2. Okay, this one is vector u. And the vector v into space, we have v1, v2. Okay, we add the vector u and vector v. So we get u1 plus v1 and u2 plus v2. Okay, the second operation, subtraction. Okay, u minus v. So we get this one. And the third one is scalar multiplication. Okay, c times u. C is a scalar. Scalar or any real number. Okay, multiple with a vector u. So we get cu1, cu2. If c or c multiple with vector v, so we get cv1, cv2. Okay, for example, okay, let u equal to this vector. Okay, v equal to this vector. Okay, find w, vector w. W1 equal to 2u. 2 times vector u. So we just use the third scalar multiplication, multiple. Vector u with 2. So we get w1 equal to negative 4, 6. Okay, multiple with scalar 2. And then, okay, number 2, W2. Okay, multiple with negative 0.5. Okay, 0.5 this one. So we get 1, negative 1.5. Okay, number W3, number 3. Okay, equal to U plus V. So add on, I use the first operation, vector addition. So W3 equal to, okay, U, okay, negative 2 plus 4. 2, okay, 3 plus 1. 4. Okay, and the last one, W4. Okay, equal to U minus 2V. Okay, we find the 2V first lah kat sini, 2V. Okay, 2V equal to 8, 2. And then we subtract. Okay, so negative 2 minus 8. So negative 10. Okay, 3 minus 2, 1. Okay, so this is example of vector into space. Okay, any question? Okay, boleh faham?
Faham.
Boleh. Faham.
Okay, we look at the basic operation of a vector in n space, R power of n. More than 2 space lah. Okay, we use the same operation as vector into space. The 3 operation lah. Addition, subtraction and scalar multiplication. Okay, look at this example. Okay, vector in 3 space. Ni R power of n lah. Vector in 3 space. Okay, so W equal to, ni sama macam tadi lah, 2 times the vector U. So we get negative 4, 2, 8. Ni boleh cari lah sini ya. V, B, C and D. Find the vector in, okay, using the basic operation, 3 operation of a vector. Okay, so the answer for B, negative 0.5, negative 2. And number C, negative 1, 1, 6. D, negative 4, 1, 0. Okay, same as example 2. Okay, this one is vector in 5 space. So R power of 5. Vector in 5 space. Sama lah. We use the 3 operation to solve this. Okay, this one addition, vector addition. This one involve scalar multiplication and vector addition. This one scalar multiplication and the succession. So answer for A, 4, 6, 2, 7, negative 2. Okay, B, you multiple the scalar lah. U with 2 and vector V with 3, multiple with 3, scalar 3. So we get 8, 13, 6, 18, negative 5. And C, okay, multiple with scalar 5, and then use succession operation. So 4, 0, negative 10, negative 17, 4. Okay. Okay, so this one is example of basic operation. Okay, look at this theorem 1, the properties of basic vector operation. Okay, for any vector u, v, and w in R of n, or in vector in n space, C and D are scalar. Okay, using this theorem or these properties, okay, we have to prove the left hand side equal to the right hand side. Okay, number 1, u plus v must be equal to v plus u. This one is addition, using addition operation. Okay, number 2, okay, u plus v plus w, okay, equal to u plus v plus w. And number 3, okay, number 3 consists of zero vector. This one is zero vector. Zero vector. Okay, so u plus zero vector equal to, okay, zero vector plus u equal to u, vector u. Okay, number 4. Okay, number 4 is consists of negative vector u. So u plus negative vector u equal to zero vector. And number 5, okay, CD is scalar. Okay, C times du, okay, equal to, okay, the multiplication of scalar CD times vector u. You can multiply these two scalar CD. Okay, number 6, C times u plus v, vector u plus v, okay, equal to cu plus cv. And number 7, okay, C plus D, the addition of scalar. The addition of scalar C plus D times U, okay, equal to Cu plus Du. And last one, 1 times U, okay, equal to U. 1 is a scalar, 1 also is a scalar. So you have to know this theorem, 8 theorem. We can use this theorem in next subtopic lah, in vector space. This 8 theorem ni. Semua ni. So question dia, you all takkan prove semua theorem lah. Dia akan pilih one or two theorem. Okay, next we look at the magnitude of a vector. The magnitude of a vector is a length of a vector. Length. Okay, panjang vector tu. Or we call it as norm. Norm of a vector. Okay, represented by the symbol, okay, of, okay, this symbol. The length or magnitude or norm of a vector. Okay, it can be calculated by using this formula. Okay, for example, in vector into space, we have this formula lah. U1 square plus U2 square, square root. We have to square root lah, square root of U1 square plus U2 square. Okay, this one vector in 3 space, in vector in n space. Okay, a vector with zero magnitude is called a zero vector and is denoted by 0. Zero magnitude. Okay, zero vector has a zero magnitude. Ya kan, contoh kita let U is a zero vector. Contoh yang dapat 0, 0 is zero vector. So the magnitude of U equal to 0 lah. 0 square plus 0 square equal to 0. A vector with magnitude 1 is called a unit vector. Okay, unit vector magnitude 1. Kita tahulah maksud dia. Maksudnya magnitude dia, example we have U equal to 1. It's a unit vector. Okay, look at this example. Okay, if U equal to this vector in 3 space, okay, V vector in 3 space, okay, find U 2U minus V, and then find the magnitude of 2U minus V. Okay, before we find this magnitude 2U minus V, okay, we have to find the vector, this vector 2U minus V. We use the previous property lah. Okay, so 2U minus V. Okay, we use the scalar multiplication lah, 2U and 2U. So equal to 4, negative 2, 16. And then we use this operation, subtraction. Okay, 2U minus V. So 4 minus negative 1, 5. Okay, negative 2 minus 3, negative 5. 16 minus 2, 14. And then we find the magnitude. So 2U minus V. Okay, equal to, okay, so 5 square plus negative 5 square plus 14 square. Square. So we get okay, so the magnitude equal to okay, berapa jawapannya? Volunteer siapa?
15.68.
Dapat berapa? Square root berapa dulu?
Square root 246.
246. Tinggalkan jawapan dalam ni pun boleh. Ataupun 15.68 unit Okay, number 2. Find U minus 3V. Okay, berapa dapat ni? Vector into space. Okay, Farhana boleh bagi jawapan. B, number 2. U minus 3V. Farhana, ada Farhana?
Dia sekejap tengok kira.
Ada kira. Okay, U minus 3V dapat apa? Dapat negative 10, 2 kan?
Ya.
Okay.
Negative 10 tu.
Okay, and then find the magnitude. So magnitude equal to
Square root
10 square
104.
plus 4 plus 2 square.
Square.
Dapat 1 square root
Square root 26.
104.
104. 4.
Square root 104 unit. Okay. Okay, ada soalan ni. Magnitude. Magnitude of a vector.
Tak ada. Faham.
Ada. Simbol dah kena ingat lah ni magnitude. Okay, next we look at the unit vector. Okay, before this, I've mentioned the unit vector is the vector with magnitude equal to 1 kan. Unit vector ni. Magnitude equal to 1. So we use this formula to convert if the vector is, if the magnitude of vector is not equal to 1. So we use this formula to convert this vector into unit vector. Okay, given a non-zero vector u in Rn or in n space, then a unit vector in the same direction as u is given by u over magnitude of u. And a unit vector in the opposite direction, okay, given by negative u over magnitude of u. Okay, we use this formula to convert. If the magnitude of a vector is not equal to 0, is not equal to 1. For example, if you look at this example 1, okay, given the vector into space, vector u. Okay, determine whether this is a unit vector or not. Okay, first we have to find the magnitude of this vector, magnitude of this vector u. So u equal to the magnitude of u equal to negative 4 square and find a magnitude of vector plus 3 square. So equal to, okay, 5 and square root 25. Okay, it's not equal to 1. So it is not a unit vector. Not a unit vector. Okay, if it's not a unit vector, find a unit vector in the opposite direction as u. So kat sini dia suruh cari unit vector. But in the opposite direction of u. So you have to use this theorem or this formula to convert this vector u into unit vector. Okay, so in opposite direction, so negative u over the magnitude of u. So we get negative of u. So 4 and 4 and negative 3. So over 5. So we get a new coordinate lah of u. So 4 over 5 and negative 3 over 5. Okay, if we find this magnitude of a new vector, we get magnitude equal to 1. This one, boleh prove balik. Dapat tak sama dengan 1? Dapat equal magnitude of this one equal to 1 lah magnitude dia. Magnitude equal to 1. Okay, dapat balik 1 kan ni? Cuba try. Proof balik.
Ya. Baik.
Dekat 1 kan? Cakap ada join lagi ni. Okay, ada soalannya ni. Faham
Tak
ni?
ada.
Faham?
Faham?
Okay, number 2. Find the vector x which has a magnitude of 10 units and in the opposite direction of u. We want to find the vector x if the magnitude equal to 10. Boleh buat equation kan? So x, the vector x over, you want to find the vector x over magnitude of x, 10. Okay, so equal to, okay, u over the magnitude of u. U, so 4, 0, negative 3. But kat sini dia nak apa? Opposite kan? Kena tengok ni lah. In opposite direction. So kena negative kat sini. 5. Okay, over. Okay, the magnitude of u. Berapa ni magnitude of u? Okay, magnitude of u equal to apa? Square root 50 kan? Dapat? Square root 50.
Dapat.
4 square plus
Dapat.
0 plus negative 3 square plus 5 square. So 50.
Dapat.
50. Then awak solve lah ni. So we get x equal to, ni buat di sini. So dapat square root 2 kan. Okay, dapat ni square root, negative square root 2 times 4. 0 square root times 3. Tak apa, buat point pun boleh. Negative square root 2 times 5. Okay. The last one. Okay, find a vector of magnitude 3 that is in the same direction of v. So first find the, okay, this equation. We want to find a new vector. For example, a new vector u. Okay, over u over magnitude of u is 3. So equal to in the same direction of v. Same direction of v, itu sama lah. 1, 2, 3. Over, okay, the magnitude of v. You get the square root 10 kan? Square root apa? 14.
14.
Pada macam ni. Kita dapatlah U equal to negative 3 over square root 14. 6 over square root 14. 9 over square root 14. Okay, ada soalan untuk yang ni? Tak ada Semua faham
Ada. Faham.
Okay. Okay, we look at the product. The product of a vector and its application. Okay, let U equal to this vector in n space, V, okay, vector in n space. Okay, then the dot product between U and V is written as U dot V. This notation. U dot V. And we can find the dot product of U dot V, okay, equal to this formula. Okay, U dot V equal to U1 V1 plus U2 V2 plus UN Vn. So the solution of the product is not a vector anymore lah. This is a real number. So U dot V. U dot V. So 1 times negative 2 plus, okay, 0 times 4 plus 3 times 1. So we get equal to 1. So we can use this dot product to find the angle of these two vector or to find the types of angle. Kita boleh tahu dia punya sudut ni daripada dot product ni. Ni equal to 1 kan. So equal to 1, we can find the types of angle. Ni boleh tahu types of angle. Sudut dia berapa. Okay, nanti tu next lah. Okay, cari dulu ni. The product of W dot V, W dot U, and this one. Okay, U dot. Okay, ni untuk this one ni awak kena use the properties of addition dulu lah. W plus V. And then baru awak find the dot product. U dot this one. Dot product of this one. Okay, W dot V. Okay, berapa? Okay, the dot product can be negative value, positive value or 0.
Negative 9.
Okay, dapat negative 9.
Negative 9.
Okay, C. W dot U.
Sixteen.
16.
Okay, 16. Okay, D. Now kena check dulu W dot W plus V. Okay, W plus V dapat berapa?
17.
Ni 17 17. Okay ni.
Okay.
Okay, next nanti kita tengoklah the types of angle. If you find this dot product, we can determine the types of angle. Okay, next is the properties of dot product. The properties. Okay, number 1, U dot V equal to V dot U. Number 2, C times U dot V equal to CU times dot V equal to U times U dot CV. Okay, number 3, U dot V plus W equal to U dot V plus U dot W. Okay, number 4, U dot U equal to magnitude of U square. And number 5, U dot U, if U dot U greater than 0, if vector U not equal to 0 vector. Okay, number 6, U dot U less than 0 if vector of U not equal to 0 vector. Maksudnya ni dia boleh U dot U ni in positive or negative value lah untuk ni. Boleh, number 5 and number 6 ni. Either positive or negative value if U not equal to 0 vector. Okay. This is a mention application of the dot product. We can find the angle of the vector, or we can determine the types of angle. First, we look at how to find the angle of these two vectors using dot product. Okay, we can use this definition or this formula. Okay, the angle theta is the angle between vector U and V. Okay, then the U dot V. U dot V equal to the magnitude of U multiple with magnitude of V times cos theta. If U not equal to 0, vector and V not equal to 0 vector. Also, U dot V equal to 0 if U equal to 0 vector or V equal to 0 vector. So maksudnya dia boleh U in 0, U dot V equal to 0 or any real number. So we can find the angle using this formula. Kita tukarkanlah dia. Theta equal to, you want to find the theta kat sini, theta. So theta equal to cos inverse times U dot V over magnitude of U times magnitude of V. Okay, yang ni U dot V equal to 0 ni sebenarnya right angle lah ni, 90 degree right angle. Degree. Okay, look at this example. Okay, find the angle between U and V. Find the angle. between U and V. So we use this formula lah. Theta equal to cos inverse U dot V over magnitude of U times magnitude of V. First, you have to find the dot product of U dot V. U dot V. So U dot V equal to apa? 1 times 3 plus -2 times -4 plus 3 times 2. So we get the dot product of U dot V equal to dapat apa? Volunteer.
17.
17
17.
17. Okay, and then the magnitude of U. Find this magnitude of U. Square root 14. And the magnitude of V. Magnitude of V.
Square root 29.
Square root 29. Then you can find the this angle lah. Okay, first you have to kena tengok punya mod of a calculator must be in degree mod lah. Kena tukar dulu mod degree. Kita nak cari dalam degree kan. Kita tukar angle unit dia tu. In degree. So boleh masukkan. Okay. Theta equal to tukar mod dalam degree lah. Shift cos. Tu kena tekan cos inverse lah. Shift cos. Berkaitan. 17 over okay, dapat berapa? 32.47 degree kan?
Dapat.
Sama.
7 degree. Okay, cuba cari B and C. V dot V and the angle between V and W, U and W. Okay, cari dulu B and C. Okay, jawapan B and C berapa?
B 103.15.
Okay. C?
Sembilan puluh.
90 eh.
90.
Okay, ni boleh eh. Okay, number 2. Cuba buat. Okay, number 2 ni awak kena tukar. Okay, ni dalam mod radian lah. Okay, number 2 dapat apa? Ni C equal to 0 eh. Dapat tak? Okay, dapat tak ni? 2. Number 2. Okay, yang ni awak dapat cos, ni awak boleh gunakan yang ni lah. U dot V equal to magnitude of U times magnitude of V cos theta. Okay, cos theta nak tukar kepada radian. So cos pi over 4 akan dapat square root 2 over 2 kan. Cos pi over 4 square root 2 over 2. Dan solve lah ni. Magnitude of U, magnitude of V. Dapat C equal to 2. C equal to 0. Boleh ni? U dot V dapat apa? U dot V awak dapat 1 plus C kan? Okay, magnitude of U dapat 1 plus C square, square root. Magnitude of V dapat square root 2. So, selesaikan lah ni. Okay, yang ni boleh cancel kan? Square root 2 is 2. Boleh cancel. So, dapat ni lah. Okay, ni nak buangkan bracket, awak kena squarekan yang ni. Dapat C equal to 0. Okay, boleh? Boleh tak?
Boleh.
Okay, so kita tengok types of angle. Okay, tadi saya mention U dot V. Okay, there are three types of angle. Okay, if U dot V greater than 0, then the angle is acute angle. Okay, acute angle ni less than 90 degree. Contohnya awak ada ni. Acute angle less than 90 degree. If U dot V less than 0, so it is obtuse angle. Obtuse angle is greater than 90 degree. Contoh ada angle, this one, angle. And if U dot V equal to 0, then it is a right angle. Okay, right angle is equal to 90 degree. We have this angle. Okay, so tadi awak boleh check yang awak dapat ni kan? Previous exercise tadi. So tadi types of angle. Okay, less than 0. It is obtuse angle. Okay, ni greater than 0. Greater than 0 is acute angle. Acute. Okay, ni obtuse. Okay, this one acute. Okay, contoh lagi tadi, kita dah cari angle tadi kan? Yang tadi ni. So tadi awak dah dapat U dot V, question A dapat U dot V equal to 17 kan? 17 is acute angle. So betul lah acute angle is less than 90 degree. Awak dapat 32.47. Awak boleh gunakan ni untuk check lah jawapan awak kan? First checking. Okay. Okay, so ni boleh gunakan ni lah. U dot V. This one ni acute, dua-dua acute. Okay. Okay, next. Okay, definition 6, the orthogonal vector. Orthogonal vector, these two vector u and v are said to be orthogonal if u dot v equal to 0. Or we call it, the angle is the right angle, right angle. Okay, boleh buat ni, cuba buat question 1 and 2. Prove that u dot v is orthogonal or not. And then find this value of c. If u dot v, if u and v are orthogonal. Okay, cuba cari ni. Sini dulu. Dengan yang tadi ni. Cari berapa ni nilai dia. Okay, tadi dapat ni. Okay, dapat berapa ni tadi?
10.
Di mana? Ni. Orthogonal. V dot V equal to 0 kan?
Yes.
So it is orthogonal. Orthogonal. Okay, find the value of C.
1.
Ada dapat 2 kan nilai dia.
1 and negative 4 over
Negative
3.
4 over 3.
C equal to 1 and negative 4 over
Over 3.
Okay. So dah habis untuk first subtopic. Besok boleh try buat ni. Okay, ni exercise after ni lah. This lecture. Okay, dalam tutorial pun untuk tutorial pun saya dah upload lah. Tutorial tu based on past year awak. For all chapter 4 ni. Yang ni awak boleh buat sendiri. Ni boleh refer dalam awak punya Google Classroom. Awak download notes yang PDF. Ni. Boleh try lah ni sendiri. Jawapan saya akan bagi. 10 question. Okay, untuk next class. Okay, saya nak awak baca dulu ni boleh? Untuk ni, real vector space. Okay, ni banyak proving lah. Awak kena prove. Yang tadi kita gunakan, kita ada juga buat calculation kan. Untuk ni second subtopic ni, real vector space. Saya nak awak baca dulu ni. Proof. Cuba proof. Ni dia gunakan sama je macam tadi. Properties properties of a vector. Cuma kat sini dia ada tambah lah sikit. Tadi kita ada 8 properties kan of vector. Ni dia ada tambah. Ni number 1 ni. Another two properties. Lagi satu dah ada tambah mana? Ni. Number 6. Dia ada tambah vector V is closed under vector addition and vector V is closed under scalar multiplication. Okay, we use these two axiom to prove another subspace. Okay, yang lain ni sama macam yang tadi, yang saya dah mention tadi. 8 properties of a vector. So kita akan gunakan 10 vector ni untuk soalan dia ni, soalan awak tak akan prove lah semua 10 axiom tu. Macam ni contoh ni kan, prove dia pilih axiom 1, Cu plus V equal to Cu plus Cv, and prove axiom 2, C and D is scalar, C plus D times vector U. So kena prove 2 axiom ni lah. Okay, using this ni yang dia bagi ni. Dia bagi ni. Okay, cuba awak tengok contoh dia nanti study dulu sendiri lah. Untuk next nanti kita boleh cepat untuk proofkan ni. Study ni, axiom. Awak tengok ni dia proof ni. Cuba buat sendiri. Tu axiom ni. Nak fahamkan macam mana dia proofkan ni. Axiom 1 fail, axiom 2 fail. Kenapa fail? Okay, boleh. Next class awak, sebelum next lecture awak kena study dulu lah untuk proving ni. Saya akan tunjuk sikit je lah proving ni. Yang lain awak kena try sendiri proof. Ni pun ada proof. Exercise untuk proof pun ni. Tutorial 4B. Okay, ni akan ditanya dalam third assessment awak. Final assessment tak akan masuk chapter 4 ni. Okay, ada apa lagi soalan? Untuk first subtopic tadi? Tak ada eh? Faham
Ada.
eh? First subtopic?
Faham. Faham.
Okay, so kita dah habis untuk first subtopic. Okay, saya jawab ni. Ni. Google Form. Okay, you future klik lah. Dah klik? You future.
Dah.
Dah eh? Dengan ni. Google Form. Okay ni. Okay, Google Form ada dalam punya chat. Okay, tak ada lagi soalan eh? Okay, kita start sampai sini eh. Okay, thank you
Baik,
semua.
Thank you.
Okay, jangan lupa siapa yang belum klik you feature, tolong klik lah.
Okay, madam.